He's by Pavel Koten. He's going to talk about a single station 2002 Leonid Meteor cluster. I set your time 17 minutes, including questions.
Thank you. Good morning to everybody. It doesn't work. No. Yes, thank you. So I will talk about one case of a meteor cluster which was recorded relatively many years ago. Actually, at this moment, we have no exact definition what the meteor clusters are, but intuitively we feel them like meteors or meteoroids, which are close in space and time and with the same radiant. There are several cases of huge meteor clusters which were recorded during Leonid meteor storms at the turn of the centuries. And in recent years, we have analyzed several other meteor clusters which were observed by our team or by other people. The last year at IMC, we have presented data on a meteor cluster which was recorded in Brazil in 1219. It consists of 10 meteors, and because these cases are still rare or the records are rare, we made a call for more data, and Bernd have offered to us his record, which was taken during Leonids in 2002. This is a composite image of the meteor cluster. There is a relatively compact group of 9 meteors and 2 other meteors which were recorded at a similar time. Our record was taken by Meteor camera with time resolution 6.25 frames per second. It was recorded in Clar Alto in Spain during the maximum of 2002 Leonids on 19 November at 3:02 UT. It was a single station observation, but it was not so big problem because we know that the meteors belong to Leonid meteors, the Leonid meteor shower. So we can suppose that we know the radiant and velocity, and we can calculate atmospheric trajectories even from the single station observation. So may I ask you for video, please? So you can see the short video which shows the meteor cluster. So there are several meteors which are visible almost at the same time, and there are 2 other which may or may not belong to the cluster. Thanks. I would like to move to another slide, but it doesn't work. So when I saw firstly the video, I was happy with it because it looks very interesting. All the meteors appear almost at the same time, and it was curious. There was a fragmentation even in the atmosphere or just before they entered the atmosphere. But it was shown that it was a little bit tricky to work with this video because as we compare today technology with techniques 20 or 25 years ago, it is the difference is significant. So there was a low spatial and time resolution, there was a higher noise, and although the observation was influenced by clouds, and when I tried to measure the astrometric calibration, I cannot put the stars from the catalog and the stars on the video together, and it was found that there is a different pixel size on both axes. So it was necessary to scale y-axis by factor 0.92, and after this, the stars fit perfectly, and it was possible to calibrate the image and measure the meteors. Another complication was that fainter meteors were recorded only on very few frames because of low time resolution. But finally, it was possible to measure all the records and calculate atmospheric trajectories of meteors and positions of meteoroids as well as their masses. Here is a 3D plot of the meteoroids in the atmosphere. You can see that there is a relatively compact group of 9 meteors and 2 other meteors which are relatively far away from this group. Everything occurred above the Mediterranean Sea, east of the Spain coast, at distances between 180 and 110 kilometers from Auto Camera, and the beginning heights of each meteor were at this range. So usually when we have data on such cluster, we look if there is some mass separation of individual fragments. It means mass separations along the axis which is opposite to the sun. And in this case, no such separation was found. In this plot, you can see the positions along this axis and the masses of all meteoroids. And it's clear that there is no mass separation, that the masses or meteoroids with different masses are found at different distances. And moreover, two meteoroids, or two meteors which were detected before and after the cluster are significantly distant from the whole other cluster. If we look on the positions in 3D, it's before the meteoroids entered the atmosphere, we can see that the group of 9 meteors is relatively very compact. It when projected on the ground, it covered only less than 1,000 kilometers square. If we include two other meteors, the ground projection is significantly higher. For the determination of the age, we usually calculate the initial kinetic energy of each fragment, and these are shown here on this plot. And for the minimum, we took the total minimum of total kinetic and initial kinetic energy of whole cluster, and it showed that the age should be around 1.5 of day. But in this case, because there is no mass separation, this is just upper limit, and the lower limit is uncertain. To show that the age is probably not higher, we can plot the ejection velocities in comparison with current position of each fragment. So these are the position of the fragments, and these are ejection velocities in the age, in the case when the age is just 6 hours. If the age is higher, in this case 1 day, the situation looks this one, and it's still possible. But if we took the age of 3 days, the ejection velocities should be in this direction. And what is more important, there is a very narrow angle of all the ejection velocities in the solar direction, and this is very unlikely, and it means that the H is probably smaller than 3 days. In such case, the ejection velocities are relatively very low, which would favor thermal stresses as possible mechanism. But because we don't know the lower limit of the H, we cannot exclude that the ejection velocities could be higher. And in this case, although other scenarios are possible. So what is it, thermal stress? It is something like cycling load, which does not exceed the strength of the material, but continuously create some cracks which grow and finally it can cause the disruption of the object. It was already observed on the Earth, but also it was observed on asteroid Bennu from the spacecraft. Here I show how the cluster looks in time scale. So we have a compact group of 9 meteors which were recorded within half a second, and there was another meteor less than 2 seconds before, and the final one which was 1 frame later after the fun. And we make a statistical analysis if such 2 meteors can or cannot belong to the cluster, because the cluster was observed at the maximum of the activity. Bernd calculated 30 meteors, including cluster, within 4 minutes. So we make a statistical simulation, and we search for 1 meteors which represent cluster and 2 other meteors at the observed times, and we look if is it a random appearance or if the meteor could belong to the cluster. And from 1 million simulations, it was found that such situation occurred at 2.7% of all cases. And if we took 2 sigma interval of coincidence, we cannot say that this is a random appearance. So it may happen that these 2 meteors can belong to the cluster, but because they are relatively distant from the compact group of meteors, we can say that if they belong to the cluster, they were ejected at different times, not as the core cluster was. So this case extend our sample of meteor cluster we analyzed in detail up to now. So this is the last column. You can see that this was a very compact cluster in terms of when projected on the ground, and also in terms of the time. It happened if we took into account only core meteors. There was no mass separation, and there was also no dominant mass body. The biggest meteoroid have only 33% of total mass of the cluster. So in this case, it was also very young cluster, and we can suppose that the thermal stress is possible mechanism, but we cannot exclude other scenario. So if we took all the data we have together, we can see that if we have absolutely mass dominant body, then we observe better mass separation, and for such clusters, we can relatively reliably determine age and also the ejection velocities of the meteoroids. And if the velocities are low, the thermal stress is the most probable mechanism. For non-mass separated events, everything is uncertain: age, reaction velocities, and also the formation mechanism. Okay. So we know that our sample is still limited. We have a limited view of our cameras of our network, so we can detect only meteor or meteoroids which are close in space and time. And for detection of cluster with a different origin, for example, with collision origin, we need to be able to detect more distant fragments, because in this case we look for higher ejection velocities. So I will finish with this question. If anybody has data on meteor shower and will be able to share with us, we will be very happy. So thank you.
Thank you, Pavel. There is time for one question. I see a raised hand, nothing online. So bring the microphone to Roman.
Thank you. Pavel, is any possibilities that some of the quasi streams in MDC are was only one body and in fact old cluster?
Yes, I think it is possible, and I can use the Tau Hercules meteor cluster, which was observed during recent peak or recent meteor activity of this, because this cluster consists of 50 meteors. They have different radiant and classical Tau Hercules meteor shower, and so they actually satisfy the condition for determination of the meteor shower, because for single station observations the condition is to have 50 meteors. So, and this is different area, but there is another condition which was not satisfied in this moment, that it was not repeated observation. But yes, I think it could happen that maybe among the older records, that some shower could be actually one cluster in the database. Thank you.
Okay, thank you, Pavel.